This video is an explanation about mean and standard deviation from a set of data. So what I started with is a group of height of men whose lowest height is 58 inches and the tallest man is 76 inches, and these are every individual's height that we measured listed from highest to lowest. Now, all I'm going to do if I wanted to by hand would be add every single one of these together and divide by how many people we had, which is 22 people. So if I was to do that, I would get this mean of 68.65, which I graphed as the green line that you see there. Now, the standard deviation is a mathematical formula, which we see here, and it's a lot of fancy terminology. First of all, what I'd really like to talk about is this summation. Oops, that's ugly looking summation of y minus y bar squared. What does that mean? Okay, let's talk about that first of all. Y bar is our mean. And in this case, it is 68.65. And then y is going to be the height of each person, of each man that we have on our data. And I'm going to take the height of the man and I'm going to subtract the average. And I'm going to show you that visually. So that's the first calculation, will be this value here, which will be a negative value. And then I'm going to take the next one and I'm going to calculate this difference and then this difference. Oops. And each one of them between the height of the person and the actual mean. And so each one of them will give me some value. And I should have a number for each one of these people. So once I find out these numbers, this means to add them, because sum or summation, to sum means to add. And sum starts with the letter S, and sigma is the Greek letter S. So this means to add all of these calculations between each person's height, the difference between each person's height and the mean. But we're not just going to add them. Before we add them, we're actually going to square them. And so we're going to add them all up, square them, add them all up, divide by how, and n is how many people we had when we have 22, I think was, or 23. 23, I think, is what we had. So n minus 1 is going to be 22 for this particular set. And then I'm going to take the square root of that value, and that's a lot of work. But that's the actual calculation. So what is it telling us? Well, this is how much there is a difference between what our average is and our individuals. So the standard deviation tells me how spread apart the data is. The more, if this person's height was down here and they were a lot more spread out, then my standard deviation would be a much larger number. So that's a lot of work, and we're not going to go through that. We're going to use technology to help us. But this is mechanically how we would actually do it if we wanted to do it by hand, and it would only be practical for very small sets of numbers. Once you get into large sets of numbers, it becomes impractical. But this standard deviation tells me basically roughly anywhere from 50 to 60% of my data is between one standard deviation of the mean. So what does that mean? So let's do the calculation using StatCruch. So here's my data. We were working on it with box plots. And now I'm going to take that variable and I'm going to do a stat summary statistics, and this is a column of data. And I'm going to pick that column and I'm just going to run it, and it's going to give me how many people n, what is the mean value, the variance, which is basically just our standard deviation squared, or you could say our standard deviation is the square root of variance. Those statements are equivalent. Okay, standard error we're not going to talk about right now, but it's also going to give us our median, range, minimum, maximum, Q1, Q3. So now we have this information here. And let's see, I'm going to bring that into my data here, and I'm going to erase all of this stuff that I wrote here. But now I'm going to insert these values. Oh, sorry about that, didn't catch them all. Oh, never mind. So I'm going to try it one more time. Sometimes my mouse gets a little bit tricky on me. For some reason, there we go. Okay. So, our standard deviation. What we would calculate by hand is calculated for us. And again, if you square this number, you will get the variance. So squaring it gives me variance. So if you know one, you know the other. And basically, we have our mean. And with this mean of 68.65, which we see on the graph, putting a standard deviation on that means that approximately 50+% of my data is within that. So this is a very similar way of expressing the idea of what we get from the IQR. And it's not the same as the IQR, but it gives us similar information about the graph. It tells me of the data how spread out it is. So you should never mistake the two as being the same thing, but they do tell me very similar, except for they're calculated very differently. Now, that's standard deviation. So basically, my average height, according to my summary statistics, is 68.65, with the vast majority of people being plus or minus 2.1 units from that. So 68. Oh, come on. Let me write it over here. 68.65 plus or minus. Sorry about that. Plus or minus the standard deviation divided by 2. So 2.1. That's half my standard deviation, which means I can find the vast majority, well, not the vast majority, approximately half of my data would represent heights between 68.65 plus or minus 2.1 inches taller or shorter than the mean. So again, very similar to the information I get from a box plot. And I'm not going to expect you to ever calculate standard deviation by hand, but really it's a summation of the differences between the data and the average value of the data.